Hey everyone, can you guys hear me? Uh, yeah, sorry for being a bit late today, but we'll start now. So, hey everyone, this is Arpit. I'm your TA for the course Introduction to Biostatistics, and today we have the ninth live session where we'll basically uh, discuss questions from all over the syllabus. So sample questions, and at the end, I have a few set of questions that I'll also give to you along with solutions so that you guys can practice on solving questions for the exam. Okay. Uh, so yeah, as always, so the live session link doesn't matter now. This is the last live session we'll be having. So the YouTube link is where you'll find all the recordings for all the classes. I have not yet uploaded the last one, but today I'll do both the last one and today's session. So yeah, you should have all of them up there for your reference. Then in the Google Drive, all the study materials for these live sessions, along with the bonus question answers, I'll upload them after today's class. Yeah. Um, So yeah, uh, does anyone have any questions or doubts before we start? Yeah, Pulkit. Yeah,
Hello,
yeah,
sir, am I audible?
yeah. You're audible.
Okay, thank you, sir. So my question is regarding SPSS software, sir.
Okay,
So what I'm currently facing right now is in SPSS, the only maximum limit of entry for one way ANOVA is 50. Like 50 samples can be, evaluated continuously. So
okay.
what should I do to use more than 50 samples? Like my treatment contains somewhere around 70, 80 samples, but while I am comparing in one way ANOVA, I'm not getting past 50.
So I didn't understand. So like you have 50 groups or 50 data points.
Sir, to be precise, I would say I have, just a second, sir. Sir, I have 81 readings, like 81 different treatment.
Reading different
Okay.
treatments.
Yes. For example, I have three plants,
Mhm.
and for each plant, I have three different extracts. And for each extract and each plant, I have three different fungus. And for each fungus and extract, I have three different concentrations.
So what are you trying to do?
Sir, I am trying to get an antifungal potential of the extracts.
Okay.
So can you please
You,
suggest me how I can break it down so that I can get the readings in spaces as in for the one where Nova? without reaching the 50 limit like this? Or is there any other tool that I can use so that I can, like compare all these treatments in a single go?
See, one very straightforward way to do that would be to basically use a general linear model or something. But that might be too complex. So what it basically will do is it'll basically fit a curve to your uh, concentration values or whatever you have, the predictor, and it will tell you how much each factor basically affects that thing. And the other thing would be you can try doing a two-way ANOVA. So two-factor ANOVA or a two-way ANOVA. In that, you can basically choose two things as factors. So maybe that way you can reduce the number of treatments that you have if you divide them into two parts. So you can do plant versus fungus or something like that. Is that
Sir, for example, for the paper recently,
a kind of theory? I think you have muted yourself.
sorry, sir.
Yeah.
Sir, the thing I am getting right now is for the paper manuscript, what we have to give is that the extracts, because we have to compare between different plants, first of all. Next,
Hmm.
the extracts. For example, we have three different extracts like ethanol, methanol, and acetone. So
Hmm.
different extracts are giving different result as in intensity and the potential of antifungal potential.
Hmm.
So we have to compare it with control as well as positive control. As in the control will be having nothing. In the positive control, we are taking a fungicide.
Yeah.
So after getting all these, incorporating all these values, it is somewhere around 81, sir. So while I was running it in the ANOVA, so after 50, it's like 50 is the limit. So should I do it manually by putting the formulas in Excel, or what else can I do? Because just doing the post hoc method, it's very convenient in ANOVA. Or can I change it like if I run it in two-way ANOVA, or for example, what I was thinking is that what I could do is, let me know if I'm right or wrong. For example, if I take control, with respect to control, if I take different treatments. So, for example, if I take control with plant one, then control with plant two. So after all these, can I incorporate the readings of the one-way ANOVA altogether?
Uh, Incorporate the readings of the one-way ANOVA as in like you do separate one-way ANOVAs and then you try to figure out like
Yes, according to a different, for example, control and plant one, I get some readings like uh, for some readings I get okay highly significant,
हाँ
okay, and significant accordingly.
आप आले
And
हाँ
for the second plant, I get other readings of highly significance. Okay, but the issue that I am facing right now is while I incorporate all different parameters along with control, the significance level of different parameters is not matching the actual bar graph.
how are you drawing? Significance level is not matching bar graph as in?
Sir, for example, if I have 10, 10 bar graphs, okay, like for 10 different treatment, I am having bar graph, and three bar graph are almost very significant to each other. If we look at, like if we look at the picture. like the bar graph of three parameters are very close to each other, then their significance to each other will be high. Am I right or wrong?
Just a second. Yeah. So, what you are saying is, for example, you have bar graphs. Let's say you have, this is what you're talking about, right? So, like, I think you have muted yourself again. Hello.
Sorry, sir. Yes, sir. In this
Yeah.
bar graph, if we, mention like 1, 2, 3, 4, 5, 6 for each bar graph, uh, can you please write yes? And if you take an example, for example, the 1 or 2 are more very much closely related. Okay.
Mhm.
So if I have incorporated all six from control, like as I earlier I told you, like 1, 2, 1, 3, 1, 4, 1, 5, 1, 6.
Mhm.
So here the significance level between 1 and 2 will be, for example, if it is highly significant and 4 and 5 is highly significant, but 4 is not highly significant to 1. Are you getting? For example, if 1 is the control and 2, 3, 4, 5, 6 are different parameters, then while we were making the one-way ANOVA, in that
Mhm.
case, the control 1 with along with 2, it was highly significant. Okay.
Mhm.
And 1 with 4, 5, 6 highly significant. But here, what we didn't do is, for example, the comparison between the role, like same. For example, 4 and 5, as we can see, they both are significant. Am I right or wrong?
Mhm.
है ना?
So when
If,
you when you're
4 and 5,
saying significant, what do you mean?
sir, I mean that the p value is less than 0.05.
That can happen for any of these, but if you have bar graphs like this, then you're more likely to see significance between 1 and 4, 1 and 5, rather than 1 and 2, because they are at the same level. So they won't be that different.
Yes, sir.
So 1 and
So,
2, 4 and 5 won't be that significant. But 1 and 4, 1 and 5 will be significantly different.
yes, sir.
Huh. So like you're doing ANOVA, so these are like your each of these bar is like for your one treatment, is it?
Yes, sir. So here the point that I want is with respect to control, we can get the significant figures. Okay. But
Hmm.
I am not getting the significant figures among the treatments. For example, if I have to say that the methanol extract
Okay.
of plants, that's
Ah,
what I am trying to ask you, sir. Like, how can I get that if I have to
so
write the discussion? So for writing the discussion, I should get, okay, if I'm getting plant two, the methanol extract of plant two is,
so you do a two-way ANOVA where you basically compare between two different categories. So you have plant and extract, right? Sorry,
yes,
plant.
sir.
What are the
Extract,
category? Uh,
sir, three plants,
hmm.
three extract, and three fungus. And one
Yes.
control, one positive and one negative control.
Yeah, so you can do a two-way ANOVA between two of these factors and then do another one between the other two factors. Or like, what do you say?
So if you could break it down for me, like how can I, compare it as in two-way ANOVA also, how will I be able to either there are two options, sir. First of all is I can screen the extracts. Like I can
Mm,
do the screening of the extracts according to the plant. For example, for plant one, this extract is the best. For plant two, this extract is the best. Same for third. Then
mm,
it can be for the fungus. For example, for first fungus, this extract of this plant is doing well. For second fungus, this extract of that plant is doing well. So, or you can give me some other example, or you can, let me how I can break it down so that I can use to a ANOVA in an efficient way. Or the criteria or the thing that I told you recently, if I break it down to, particular extract, particular plant, and particular fungus, then can I incorporate it in the one way ANOVA?
So your end goal is to basically say, like, make what statement?
So the end statement will be this plants, for example, the plant one methanol extract is effective against fungus one.
Mm,
Okay. And for plant two, this extract is effective against fungus two.
mm.
So basically, what I want is I want the extract against each fungus. It could be a single extract, it
Ah,
could be a double extract. But to compare it with the rest of the extracts, okay,
so
for the
you
discussion
basically
part of this,
take
to
these differently. Since you're not interested in the interaction between all the three fungus, right? So you take for fungus one, you do a two-way ANOVA between plant and extract. For fungus two, you do another two-way ANOVA between plant and extract. And for fungus three, you do another between plant and extract. So this is for fungus one, this is for fungus two and fungus three.
okay,
Then
sir.
this one will give you basically for fungus one, what is more significant among like plant and extracts, which combination is what is best for dealing with fungus one. Then for fungus two, you can get that here. And for fungus three, you can get that here. Right.
Okay, sir.
So
So
since you have two
one last,
categories now, you can do two and one.
yes, sir. If sir,
Yeah.
I eliminate the plant part.
You
Okay,
can
for
do
example,
either
if
eliminate the plant or the fungus, whatever is more appropriate for you.
okay, if I eliminate the plant part, then the extract and fungus they will be
Hmm.
taken in one way and over.
Two and one.
Both of them
Both of them together, yeah,
with respect to control.
with respect to control.
Okay.
Yeah.
Thank you, sir.
So we'll get started. So the first question is, which of the following is inferential statistics? Option A, calculating the mean height of students in a sample. B, using a sample to predict the population mean. C, drawing a histogram. Or D, reporting standard deviation. So what do you guys think is the answer here? Today we'll have like mostly easy questions, small questions like this. And yeah, you guys can answer. Okay, so someone is saying drawing a histogram. Does anyone have any alternate answer? Okay, so we talked about two kinds of statistics. One was descriptive statistics. The other one was inferential. So in descriptive statistics, we basically describe things. For example, calculating the mean, drawing a histogram to describe the data, or reporting the standard deviation. So these are all descriptive statistics. Inferential statistics is when we basically calculate values in a sample and try to extrapolate that to the population or predict patterns in the population. So the answer here will be option B, which now people have also pointed out. So the next question is, which graph is best to show trend over time? A, pie chart, B, line graph, C, scatter plot, or D, histogram? So what do you guys think is the answer here? So the answer here is clearly B. So a line graph is what you use to show trend over time, because you can have time on the x-axis, which is a continuous variable, and you have whatever you want to put here, y or f of x or f of t actually. And it basically shows how something is a function of time. Right. Yes, the correct answer is option B. The next question is, the weight of 20 infants is recorded. Which measure of central tendency is least affected by outliers? Someone says B. Other people also say B. So the answer here is clearly median, because, sorry, median is the least affected by outliers, mean is the most affected by outliers, and mode can be affected by outliers if there are a large number of them. Right. Next question is, the mode of the data set 24468 is dash. Yes. So the answer is option B, because 4 occurs the most number of times. That's why this is the mode of the data set. Right. The next question is, which is not a measure of dispersion? A, variance, B, standard deviation, C, median, or D, range? Yes, the answer is C, median. Variance, standard deviation, and range are all measures of dispersion. Mean, median, and mode are measures of central tendency. So basically, if you have a distribution, your mean, median, mode tell you where your data is centered, and your range, your variance, or your standard deviation basically tell you how it is spread. Right. So I think it is completely MCQ based. You might have some places where you might have to calculate and enter an answer, probably. But it will be similar to what you have in your assignments. Right. Next question is, variance is A, square of the standard deviation, B, square root of the standard deviation, C, equal to mean deviation, or D, twice the standard deviation. Okay, so the answer here, as pointed out, is option A, square of the standard deviation. Standard deviation is this, variance is represented as sigma square, sigma and sigma square. Standard deviation is dash. A, root mean square deviation from mean, B, arithmetic mean, C, mode of the dataset, D, median of the dataset. So what will the answer be here? Yes, the correct answer is A, because standard deviation is defined as root mean square deviation from the mean. So we did subtract the mean, you square it, and then sum it and take the mean root of it. That is called a root mean square deviation. Question number 8. So according to Chebyshev's theorem, at least what percent of values lie within 2 standard deviations of the mean. So what do you guys think is the answer here? Someone says D, someone says B. So according to Chebyshev's theorem, if you want to look at values, the percentage of data between k standard deviations from the mean, percentage of values between k standard deviations from the mean is equal to 1 minus 1 by k square, approximately. So this is basically Chebyshev's theorem. So what it tells you is that if you have a distribution like this, and where you basically have your mean somewhere here, and you have a standard deviation. So if you take from minus x sigma to x sigma, right, in this range, what is the percent proportion of the data that is present here? So proportion of data in this range is given by 1 minus 1 by k square. This is basically Chebyshev's theorem. So according to that, since we are looking at 2 standard deviations from the mean, so our k value is 2. So the percentage of values within 2 standard deviations will be 1 minus 1 by k square, which is 1 minus 1 by 2 square, or 1 minus 1 by 4, which is 3 by 4, or 75%. So the answer here will be option B, 75%. Okay. The next question is, if z is equal to minus 2, the data point is A, 2 standard deviations above the mean, B, 2 standard deviations below the mean, C, equal to the mean, or D, an outlier. So what do you think is the answer here? If something has a Z of minus 2, what does that tell you? Exactly. So the answer is B, 2 standard deviations below the mean. So a Z score is basically how many standard deviations above or below you are with respect to the mean. So if a Z square is 1, that means the point is 1 standard deviation above the mean. And if Z score is negative, for example, Z equal to minus 3, that means the data is 3 standard deviations below the mean. Now, if the Z score is 0, what that means is basically the data is at the mean value. Okay. Next question is for data set 10, 12, 14, 16, 18, what is the variance? So you can ask you guys to solve this and tell me what answers you get. Okay, so for these questions, we'll start solving here also. So what we need to do for this data set to calculate the variance is So our variance is basically given as x minus mu whole square summation by n. Right. So we have x, which is 10, 12, 14, 16, and 18. We need to first calculate the mu value, which is nothing but summation of x divided by n. N here is basically 1, 2, 3, 4, 5. So mu will be summation of this. 12, 12, 5, 7, 70. So mu is basically 70 by 5, which is 14. Now we calculate x minus mu. We make it on this table, so it's easier. So 10 minus 14 is minus 4, 12 minus 14 is minus 2, 0, 2, and 4. Then we have x minus mu whole square. So 16, 4, 0, 4, 16. And then we take sum of this, 20, 20, 40. So now we can calculate sigma square is equal to x minus mu whole square summation divided by n. So we have calculated x minus mu whole square summation, which turns out to be 40 here. And our n value is 5. So 40 by 5 is 8. Answer here will be 8. The variance is 8. X minus mu how? So basically we have x and we calculated mu to be 14, right? So x minus mu is 10 minus 14 is minus 4, 12 minus 14 is minus 2, 14 minus 14 is 0. Similarly, right? Then we have x minus mu whole square. So we just square these values and then add them up, right? Does anyone have any questions here? Okay. The standard error decreases when A, sample size increases, B, sample variance increases, C, population mean increases, or D, sample mean decreases. So what do you think is the answer here, guys? A. Great. So standard error, the formula for standard error is basically sigma by root n. So we can see that it is inversely proportional to n uh, and directly proportional to sigma, the standard deviation. So what this tells us is that as n increases, the standard error should decrease. So as sample size increases, the standard error decreases. Okay. Next question is the correlation coefficient lies between A 0 and 1, B minus 1 and 0, C minus 1 and 1, or D 0 and infinity. C. Perfect. So the answer here is C minus 1 to 1. Correlation can be negative, can be positive, but it can maximum go from 2 minus like 1. So 1 or minus 2. Right. If R is equal to 0.9, then the correlation is A weak positive, B strong positive, C weak negative, or D none. What do you think is the answer, guys? B. Yes. So the answer here is strong positive. So if you have R square value, which is very high, so ideally 0.7 and above, you'll say that it's strong. It's a strong relation. And if it is positive, then it's a strong positive relation. If it's negative, that means it's a strong negative relation. If it is somewhere like in 0.3, 0.4, 0.2, you say it's a weak relation. And if it's positive, you say it's a weak positive. If it's negative, you say it's a weak negative relation. Hmm. So the regression equation is given y is equal to 2x plus 5. Predict y if x equal to 4. It's quite simple. So y is equal to 2x plus 5. X is given as 4. y is equal to 2 into 4 plus 5, which is 2 into 4 is 8, 8 plus 5, which is 30. Great. Good job. The next question is, interpolation is used for A, estimating within the range, B, estimating outside of the range, C, extrapolation, or D, correlation. Yes, the answer is A, estimating within the range. So if you're estimating outside the range, it's called extrapolation. So option B and option C are the same. Now, if probability of event A happening is 0.4 and probability of event B happening is 0.5, and we know that A and B are independent, what is the probability of A and B happening together? Probability of A intersection B. What is the answer here? Okay, someone said the answer is A. Does anyone have any other answers? Someone says C. So if you remember, when you say that two events are independent of each other, that means that the probability of the occurrence of one does not affect the probability of occurrence of the other, right? So in that case, probability of A intersection B is nothing but probability of A into probability of B, right? So the answer here is 0.4 into 0.5, which is 0.2. The answer is option B, 0.2. Right. So if since A and B are independent, that means A intersection B is probability of A into probability of B. Okay. Next question is the probability of getting a 6 when rolling a fair die is dash. So this is a simple question. Yes, the answer is C, 1 by 6. The next question is how many ways are there to arrange the letters in the word stats, S-T-A-T-S? Okay. So how many ways are there to arrange these letters? Okay, can someone tell me how we solve these kinds of questions? Okay, so the question is how many ways are there to arrange the letter in stacks? Right. So how do we solve these kinds of questions? Someone says it's A60. Okay. So what we basically do here is, since we have 5 letters, they can be arranged in 5 factorial ways total. But since we have some letters that are repeating, right? So for example, we have S that is repeating. So we have two S's. That's why we have divided by a 2 factorial, because 2 factorial of the combinations, the S will basically be the one that is jumbled up. So that does not. So basically STATS is the same as STATS, even if you switch this, right? Similarly, we have T, which occurs twice. So again, another 2 factorial. So the number of combinations that we have will be 5 into 4 into 3 into 2 into 1 divided by 2 into 1 to 2 into 1. So we cut this. So we have 5 into 3 into 2. Sorry, 15 into 2, which is 30. So the answer here is option B, 30. Right. The next question is from 5 men and 4 women, the number of ways to form a committee of 3 with at least 1 woman is dash. So how do you tackle these kinds of questions? So just tell me, like, how will you go about solving this? Like, what is the formula that you will use? Or yeah, okay. In combination. Yes. So total number of combinations, men and women, all included, will be 9C3. So you have total 9 people, and out of that, you are basically choosing 3 people for a council, right? So someone says it's 5C2 into 4C1 plus 5C1 into 4C2 plus 4C3 or 9C3. Four C3 divided by 9C3. Okay, so that's a way to think about it, which is slightly more like it's easier to think about. You are just taking all the cases where there's no women in the committee, 1 woman in the committee, sorry, 1 woman, 2 women, and 3 women in the committee. That part I understand. But it's easier in cases like this when you have basically with at least 1 woman, right? So what that means is, so number of committees with at least one woman is equal to total number of committees minus committees, number of committees with only men. Right. So that's another easier way to think about it. So we know that the total number of committees or total number of combinations is 9C3 because you have total 9 people. Out of that, 3 people you have to choose to make a committee. And the total number of committees with only men would be, since you have 5 men, it will be 5C3. Right. So all the committee members are men. So total number of committees with only men. And if you do that, it turns out that we have 9 factorial by 3 factorial into 6 factorial minus 5 factorial by 3 factorial into 2 factorial, which was 9 into 8 into minus 5 into 4. This is 84 minus 10, which is 70. The answer is 70. Right. So number of committees with at least one woman will be total number of committees minus committees with only men. Right. If you do that, you get this answer, which is 75. Now, this is an easy one. What is the probability of drawing an ace or king from a standard 52 card deck? We have 52 cards, all of which are different. What is the probability of getting? So if you are taking out one card, what is the probability of that card being an ace or a king? Yes. So total number of ace you have is 4. Total number of kings you have is 4. Total number of cards is 52. So the probability will be 8 by 52, which is nothing but 1 by 13. Right. So the next question is, here it will be 8 by 52 since you have 4 aces and 4 kings. Right. Yeah, it's odd. You can also unmute yourself and talk.
Hello.
Yeah.
Sir, regarding the exam on 20th, so
Yeah.
will we be getting the exams, the questions to be same as that in the assignments or and the practice session?
It will be similar, but the actual questions will be slightly different. It will be similar to what we are solving and what you have in the assignments.
Okay, sir. And one more thing, sir, can you please break down the certificate and the minimum marks required?
So for that, you need to check the announcement page. I am also not sure about that. Right. So I think in the announcement page somewhere they'll be telling you that in the course announcement or course description page, it will be clearly mentioned. Right. Okay. The next question is, which of these following is a discrete random variable? So A is height of a student, B is weight of a cat, C is number of children in a family, or D is none of the above. What do you think is the answer here? C. Correct. So the answer here, correct answer is C, number of children in a family. Discrete random variable are variables which take on discrete values. So number of children in a family will only have discrete integer values, 1, 2, 3, 4, 5, 0, something like that. Whereas weight of a cat or height of a student can have continuous values. It can have 46, 47, or some, it can also lie anywhere in between them. Right. So therefore, these are continuous, and this is discrete. If x can take values 0, 1, 2, 3 with equal probability, what is the expectation of x? You think is the answer here? It's very simple to do. So we can either use a table to do this, or we can simply, since it is mentioned that x can take the values of any of these with equal probability. So that means all of them are having equal probability of occurring. It can be 0.25, it can be 1, it can be 10. Sorry, it'll actually be 0.25 because all of them should add up to 1. So one way to do it is basically we have xi and pi, and you basically write xi pi, and your expectation of x is nothing but summation of xi pi. Right. The other thing is when you have equal probability, you can write E of x is nothing but mu, or the mean of x, which is 0 plus 1 plus 2 plus 3 divided by 4, which will be 3, 4, 5, 6, 6.4, or 1.5. Right. Now, if you do it this way also, you will see you have basically 0.25, 0.25, 0.25, 0.25. And here XIPI is 0 into 0.25, which is 0. 0.25, 0.5, and 0.75. And if you take the sum of this, you have 0, 6, 7, 5, 1.50. So if there's equal probability, you can just directly take the mean, just like this. Or if you want to go this way, you can just write down XIPI, multiply them, and take the sum of that. The next question is the mean of binomial distribution with n equal to 10 and p equal to 0.3 is dash. So who can tell me what is the formula of mean for binomial distribution? So for each of these distributions that we learned about the formula for mean, variance, right? Yes, yeah. So the formula for mean of the distribution, binomial distribution, is n into p. In this case, it will be 10 into 0.3, which is 3. Right. Now the next question is variance of binomial distribution with n equal to 20 and p equal to 0.5 is dash. So for the binomial distribution, the formula for variance is given as, who can tell me? NCQ. Perfect. So we have P equal to 0.5, Q is nothing but 1 minus P, which is 1 minus 0.5 or 0.5. Now we can write N equal to 20, P equal to 0.5, and Q equal to 0.5. So 20 into 0.5 is 10 into 5. The answer here will be 5. Right. Now the next question is, if mean number of events per hour is 3, the Poisson probability of 0 events in an hour is dash. So for the Poisson distribution, we have our mean number of events, which is 3, which is again for the Poisson distribution is lambda. So we know that probability of x, if for a Poisson distribution, is given as e power minus lambda into lambda power x divided by x factorial. So what we are asked is probability of 0 events, and we substitute lambda is equal to 3 and x equal to 0. So 3 raised by 0 is 1. 0 factorial is 1. So this becomes e raised by minus 3, which is approximately 0.0498. Right. Yes, 4.98%. So today I'll be uploading the recording of both the 8th week problem solving session and today's session, and also I'll be uploading a set of extra questions that you can go through. Okay. So question number 26, in normal distribution, about 95% of the data lies between 1 standard deviation, 2 standard deviation, 3 standard deviation, 4 standard deviation. Yes, correct. So the answer is 2 standard deviation. In a normal distribution, about 95% of the data lies in the 2 standard deviation. Now 27, if lifetime of bulbs is given as exponential function with lambda equal to 1 by 1000, probability, what is the probability that a bulb lasts for more than 2000 hours? Right. So we are given that lambda is equal to 1 by 1000. In the case of exponential distribution, we know that lambda is 1 by mu. And for our exponential distribution, to find the probability that x is greater than x, it is given by e power minus lambda into x. So probability that our bulb will last greater than 2000 hours is given as e raised power minus lambda is 1 by 1000 into x is 2000, which is e raised power minus 2000 by 1000, 2 by 1, which is e raised power minus 2. Right. Yes, correct. 0.1353. The next question is, the exponential distribution is A, memoryless, B, symmetric, C, discrete, D, binomial. So what is the correct answer here? A, memoryless. Perfect. So the answer here is A, memoryless, because the exponential distribution is not symmetric, discrete, or binomial. Next question is, standard normal distribution has mean of dash and variance of dash. So we're talking about standard normal distribution. So who can tell me the answer? Yes. So a standard normal distribution is a normal distribution that has a mean of 0 and variance of 1. So here it's 0, here it's 1. The next question is the central limit theorem states that A, sample mean distribution tends to normal as n increases. B, sample mean always equals population mean. C, population becomes normal for large n. Or D, variance always decreases. Yes, the correct answer is sample mean distribution tends to normal as n increases. So as you take more and more samples and you take the mean of that, the distribution of the mean sample means that you get tend to be normal as more and more number of samples you take, or as the number of things in a sample you increase as the sampling number. What is the formula for standard error? It's we discussed that slightly before also. Also, who can tell me what's the formula? So the answer is sigma square by n whole root or sigma by root n. Okay. Next question is for sigma equal to 10 and n equal to 5, what is the standard error? The standard error we just discussed, it's sigma by root n. So what's the answer? Perfect. So it's 10 divided by 25 root, which is 10 by 5, which is 2. For 95% confidence interval, the Z critical value is dash. Yes, so the answer here is 1.96. Right. For 98%, it's 2.33. For 99%, it's 2.58. Confidence interval width decreases when A, n decreases, B, variance increases, C, confidence level increases, or D, n increases. The confidence interval, width of the confidence interval is what we are going for here. Right. So confidence interval width is actually proportional to sigma by root n. Right. So as n increases, the confidence interval width decreases. As n increases, the confidence interval width decreases. Now confidence level increase. So that means if you go from 95% confidence level to 95% confidence level. So that is an increase. Here you'll actually have a confidence interval which is smaller than the confidence interval here because you are more confident in this range, but less confident in this smaller range. Okay, does that make sense? So if you have a larger range, you can be more confident of your prediction. Right. This is false. Variance increases, then confidence interval width increases, not decreases. And as n decreases, the CI width also increases. Right. Now, the next question is null hypothesis is dash. A, assume true unless evidence suggests otherwise. B, always false. C, always true. Or D, equal to the p-value. Yes. So the answer here is option A. The null hypothesis is always assumed true unless you have evidence that can prove otherwise. Right. Next question is type 1 error occurs when A rejecting true H naught, B accepting false H naught, C both, D neither of them. Yes, so the answer here is A rejecting true H naught. So let's say you have the truth, says H naught is true, H naught is false. Then you have the decision based on your test. H naught is true, H naught is actually rejected. Right. So if your H naught is true and it is accepted, you are doing correct. If your H naught is false and it is rejected, you are doing correct. If your H naught is true but it is rejected, you incur a type 1 error. And if your H naught is false and you accept it, you incur a type 2 error. Right. The next question is two-tailed z-test at 5% level rejects the H naught if the value of z is greater than dash. So basically, what is the Z critical value for a two-tailed Z test at 5% significance level? So alpha is 0.05. 95% confidence. Yes, the answer here is 1.96. Because if you are doing a Z test, two-tailed Z test, and your value is anywhere below minus 1.96, 1.96 is the Z value. So anything here or anything here, if you have value, it will reject that. In a one sample t-test, what is the degrees of freedom? So how do you calculate the degrees of freedom in a one sample t-test? Yes. Answer here is n minus 1, where n is the total number of data. Right. The next question is, if p-value is less than alpha, our conclusion should be dash. Yes. So basically, both of these terms, you can think of them as areas under the curve. So our alpha value is basically this area plus this area. So the total area that is beyond these critical points. And if your p-value is less than this, that means your p-value occupies less area than this. That means your z value is somewhere here. and therefore your p-value occupies only this much area, right? Is that observed? Right. So if your p-value is here in this case less than alpha, less than the alpha value, then that means you have to reject H naught, right? So your p-value is basically the area. So if the area that you are having is less than the area that your significance level or your alpha value has, that means you have to reject your estimate in favor of the parameter hypothesis. The next question is paired t-test compares A, independent groups, B, frequencies, C, difference within the same group, or D, variances. Yes, so the answer here is C, differences within the same group. So when we do, there are three types of t-test. One is a one sample t-test, where you are basically testing if the mean of a sample is equal to some value that you know. So that is your null hypothesis. Then we have two sample t-test, where your hypothesis is basically mu1 is equal to mu2. So you have two samples and you're trying to see if the mean of both of them are the same or not. Then you have paired t-test, where what you have is basically mu before treatment is equal to mu after treatment. So you have a treatment that is being given to a sample. So you have one sample, receives the treatment, then you have the sample. Here you measure mu before treatment, here you measure mu after treatment. And you compare these two using a paired t-test. Right. So it reflects on differences within the same group of individuals or same group of people. Next question is chi-square test is used for dash. A, mean differences, B, variance equality, C, frequency counts, or D, regression suite. Okay. So the answer here is actually C, frequency counts. So a chi-square test is generally used when you have frequency data or you have count data and you want to see if your observed pattern is the same as something that is calculated. One of the assumptions of chi-square test is that the variance of all your samples are the same. That's also the assumption of ANOVA. But chi-square test is actually used when you are dealing with frequencies or count data. Right. And the next question is in ANOVA, the F statistic is calculated as dash. So what is the formula for F? Yes. So in ANOVA, F ratio is calculated as MST by MSE. So this is mean of sample treatments, is mean of sample errors. So this is between groups And this is within groups. Okay. 43. ANOVA null hypothesis states that A, at least one mean differs, B, all means are equal, C, variances are unequal, or D, regression holds. Okay. There's, so what will be the answer here? What is the null hypothesis of ANOVA? Okay, I answered everything apart from the answer. So in ANOVA, you have multiple populations or multiple treatments, each of which give you a mean value. Right. So in our ANOVA, our null hypothesis is that all of these means are equal. So our null hypothesis in any case, in general, is a hypothesis of no change or no deviation. Right. And your alternate hypothesis is basically that at least one of the mu is different. Right. So the answer here is option B, all means are equal. Right. Again, you can look for the announcements in the course. They'll have an announcement or a syllabus part in the course introduction where they'll talk about how many questions will be there in the exam. Generally, it's for 100 marks, I think. Okay. Next question is, in regression, R square is dash. So what is the formula of R square and what does it represent? We talked a bit about this in last class also. Yes, so R square gives us goodness of fit. Can someone tell me what is the formula for R square? Yes, it's 1 minus SSE by SST or SSR by SST, where SST is sum squares total, SSE is sum square error, and SSR is sum square regression. Right. It basically tells us what is the goodness of fit and how much variance of y is explained by x. Right. Next question is, if F statistic in ANOVA is large, B, A fail to reject H naught, B reject H naught, C accept that all means are equal, or D none of the above. What do you think is the answer here? Yes. The answer here is 2. It is red test not because your F statistic should ideally be 1 if it is for under the null hypothesis everything is true. If F is very, very large, that means in general you reject the null hypothesis. Right. So these are basic. So I had a set of 45 questions that we were supposed to discuss in the class today. And then I have a few bonus questions from each of the topics, which are mostly numericals that you would need to solve, which will also help you clear your uh, clear your doubts, or if you have any questions about how to solve questions and all, I'll provide the solutions. So for now, you can just go through these questions, and if anyone has any doubts about how one of them will be solved or something, we can talk about that. But like these are questions I won't be solving today. I'll just give you hints about them if you want. We'll just go through all the questions and then we can stop the class. Then basically in the drive folder, I'll upload these questions along with the solution. Okay, so Pradeep is asking how to solve question number 3. So we talked about Chebyshev's theorem, which basically tells us how much percentage of values lie between X standard deviations of the mean. So here you have the mean, you have the standard deviations. You have to figure out basically the range. Is it like how many standard deviations away from the mean is it? And then use the formula that we used, 1 minus 1 by k squared. Right. You can try solving these questions and see if you're getting stuck somewhere. I can basically tell you, give you hints on how to solve them. If you guys have other questions or doubts also, we can discuss them. So all the class recordings will be are uploaded on YouTube. Almost all of them except the last one in today's class, which I'll do. So I'll just the link. So here is basically the link to the YouTube channel. You can go there and look for the playlist called Introduction to Biostatistics. That's where all the videos will be present. If you guys are also interested, there's another playlist called Biostatistics and Experiment Design. That's also something you can check out. It's not exactly related to the class, but it's similar. So this is the next set of questions. You can like go through them and be answering. So uh, all topics will have fairly equal amount of questions, I think, but importantly, you should mostly learn how to solve these kinds of questions. For example, the probability ones or the ones related to t-test and all, how to solve and arrive at correct answers. So that would be more useful. So like try practicing these questions and all. So yeah, biostatistics is generally included uh, in pharmacy because you need a lot of statistics if you're doing things like drug testing. Uh, and yeah, so screening and trials, human trials or experiments if you're running on drugs to see if like they are doing what they're supposed to do, how many samples you should take, and what should be the proportion in which it should work and so that it gets approved, so on and so forth. So those kinds of things, those experimental design, control, placebo, hypothesis testing and all, that's generally where this all the statistics is useful in pharmacy. Yeah. So eighth class I will upload today. Actually, I just upload it now. Sorry. Thanks for attending the class also. Yeah. So great to see such positive response from you guys. So does anyone have any doubts in any of these questions or would like to know how any of these can be approached? We can talk about this or move on to the next set of questions. Here is the link to the eighth class. I don't think it works right now, but I'm still uploading it. But I think in some time in 10-15 minutes, it should start working. Right. So if no one has any doubts on any of these questions, the next set of questions basically this, where we talk about different distributions and how to solve questions based on them. Okay. Someone said question number 8, right? they are given the correlation between X and Y, right? So the correlation coefficient is 0.8. You have the standard deviation of X and standard deviation of Y. You just need to find the regression slope of Y on X. So that is basically if you draw a relationship between X and Y, what is the slope of the line? So you can, if you go back to the classes, you will see that we have a formula of the regression slope that basically relates to the standard deviation and correlation between these two variables and how we can use that to get the regression slope. So you can just use that formula directly to get the regression slope of y on x. Right. Was that clear? So I think if you solve all these questions, the extra questions also that I have sent, plus attending all these classes and solving other assignments, that should be sufficient for your final preparation. But if you feel like you are unsure, it's probably always best to like solve a few more questions or yeah, so you can basically try and find more questions to solve. Right. Which might be similar to this, or basically just brush up your concepts and how to solve questions. So I have tried to include many different kinds of questions so that this should be enough for you to prepare or at least know how to tackle a question. Okay. So next we have these sets of questions on different distributions, binomial, exponential, normal, and uniform. Right. So does anyone have any doubts on solving any of these questions? Now the next set of questions on central limit theorem and confidence intervals. So I've uploaded tables into the Google Drive. So for now, you have the standard normal table there. If you guys want, I can upload other tables, but you can easily find all of them online. In the exam hall, I think you will be given all these uh, tables. So if you ask for it, standard normal chi-square table or uh, F table for ANOVA and all, if you're doing questions. Or if not tables, you will at least be given what is the critical value for whatever you need to calculate, right? So you won't be needing that. Next set of questions is on hypothesis testing and t-test. They're very simple. You just have to calculate the z-test or t-test statistic and test. Now, this is the last set of questions on chi-square test, ANOVA, and regression. If you have any doubts on how to solve any of these, feel free to ask for now. If you go to this drive link that I have shared, you will find materials for all the live sessions. And basically, there is a uh, uh, document PDF called recap problem set. And also share the link here. So this includes all the 30 recap questions that I just showed. So along with their solutions, so you can just try and solve these questions. And if you have any issues, look at the solutions that are present. And if you still have any doubts, feel free to ask in the announcement tab. Or if you want, you can also email me if you have any doubts. I'll share my email address. But it might be best to just ask on the discussion board. someone or the other will answer even if I don't answer. So be sure to write full questions. And that's the answer. Ask the questions. Yeah. There in the drive link, you can find one set on R. So where we talk about different examples. I am not sure whether you will be asked R questions in the exam. Because that was only taught in one session and like very little of it. But if you want, you can, it will be very simple about like what all different things do in R, and what all different commands do in R and all of that. So it will be quite basic. So I think you just recap that class and that will be probably easy for you to answer if any questions comes from that. Okay. Again, like if you ask questions like this in the discussion forum, it will be better because I am not involved in any of the grading or evaluation with regards to the post. Okay, so these kinds of questions are best asked on the discussion forum. So if you go to Q&A section, you'll see. Okay, I'll be here for another 5 minutes. If anyone has any questions or doubts, we can discuss that. Otherwise, we will stop here. And I'll not here. In 5 minutes, we'll stop and I'll basically upload the video for this week. I think the yeah, so the video for last week's session is uploaded, and I think it is available to view. Share the link. Okay, so yeah, I uploaded the last week's session, and is a final 9th session, which I'll upload in some time. And today or maximum by tomorrow. I've already uploaded the recap problem set, which you can go through. Just I also uploaded the PDF for today's class, along with the questions and the bonus questions. In case you don't need answers, you can just look at these and solve. I'll yeah, mostly by tonight I'll upload the rest of the things, and you can then go through that. Right. Does anyone have any other questions or doubt? I see a few people typing something. So like, if you guys have any doubts or questions, please feel free to ask. We might not get a chance to talk after this. Yeah, I've provided my email ID here. In case you have any doubts on the bonus questions or something, we can talk about that. Feel free to write me an email, but I might not reply very quickly. So it might take some time to get a reply. Okay, so we'll stop here. Thank you guys for attending the class, and I hope you have a nice exam. All the best for your exams. And yeah, if you have any doubts or any questions, feel free to email me or ask on the discussion forums. Uh, yeah, it was nice teaching you guys. And yeah, hopefully you'll all do well in your exams. Okay, thanks. Yeah. Uh, bye. We will stop here.